Okay. So, dear friend Connor, can you hear me just fine?
Do what?
Can you hear me?
Yeah, I can hear you.
Okay. Uh, my computer's lagging like a little bit, but this is Calc God. I'm beginning to feel like a calc god, All my nerdies from the A to the B nod, because it's usually an area from A to B when you're doing calculus. Now, who here knows the area under the curve parts? Because that's a thing. If you don't know, then you got no shot. Give it to robots. A commentary on current technological innovations. But to pass math like a calculator just takes class. Gotta go to school, kids. Get a textbook in your back pocket. It's very big, but it'll fit. Integration is a sum of this, taking boxes of delta x of sizes infinitely small n, numbers of the said minuscule sized boxes, with the n approaching infinity, limit, it's another word for the limit, the boxes are placed under the curves, averaging out post adding for area. Fundamental calcaholic, derive all this. So that's a basic summary of like the main thing that you use for functions in calculus. Calcaholic, derive all of this. This integrity, shady, foreboding math crap. All you need is the antiderivative of the function, either x or y. Trying or wait, what? Oh no, crying or die in the light of this fight. Flight height. By night ignite. Bye to the bye. Some Eminem inspired rhyming there.
Mm.
You're heading out now. Yeah, right.
Slap, a cutting to get, a student a snack.
Yeah, exactly. Here, I'll
Student a
recite it. I'll recite it fast.
rap, bring the track.
This integrating, shady, foreboding math crap. All you need is the antiderivative of a function, either x or y. Crying or die in the light of fight, light, height, by night, ignite, bye to the bye. You're heading out. Yeah, I'm right. Now attempt these expert God mathematics and get to practice in that. You are now able to get the grand area total by using the integration of variables and calculate the remains. Only realize you sub A and B in. B is first, math and subtract. So, I don't know how to describe that in calculus, partially because I don't remember it, because that was 5-6 years ago, and partially because I believe what I was trying to get at is in order to find the area by using variables, you basically replace part of the function, and then you replace one part of the function, a second part of the function for like the opposite side of the area, and then you subtract what's missing. So it's kind of like finding the area of a triangle. If you have the area of the square and you have the area of one triangle inside of that square, you can discover what the area of the other triangle is in that same square, because the square is just two triangles. It's kind of like that. So what to learn now? All you got is integration, but wrath of the math. Students having a bad class period. Get out your notepad. This may make you unfortunately mad. Sit, my lad, while I masterfully lay down some more rules for this. Yeah. Calc is hard, yo. Because I'm beginning to feel like a calc god. All my nerdies from the A to the B nod. You got to learn integration when exponents drop. So when doing derivatives, you can take the exponent of one part of the equation and bring it down and multiply by that number in order to get a derivative of a function. It's a little weird, that thing, but it's a nice trick. Then you use UDU to substitute all. UDU is like a very fun Yiddish call you you. But it's also a way of substitution. Now, exponents give integration problems with variables that can be quite hot. So, exponents are a pain in the butt. In order to fix your exponents, either bring it up or just jump fence. So, get out of there. Natural log, the function to make sense. Natural log is another way of calculating what you're trying to do, but it's kind of a pain in the ass because it's like the long form way of doing calculus, if I remember correctly. But to integrate like you would plopping higher power and such sign pew for it being done. It'll work it'll work all right in school if it's a lone x, or should I say just a variable you integrate. Flying solo not within parentheses, because it gets tougher to go do. Ain't cool with other stuff, fool. Chilling out along now, please shoo. Get out of here. Separate here and integration. I believe what 2014 Jordan was trying to say was you can do a natural logarithmic function if it's a simple problem. But when it gets more complicated, when it gets more complicated, it becomes a right pain in the butt. So you don't want to do that every time that you.
I you know, when I'm like crunching some logarithmic functions, you know, I'm just
natural logarithmic functions, which means it's even weirder.
Oh God! That has severely changed the situation in a way that I understand.
Yeah.
And it is inconvenient to say the least.
Oh, here we go. So, the next part I think demonstrated my previous point. Obviously, there are some functions that suck. It's censored. So boop. This is a situation where we may not want to might not want to use something we call U substitution to win. So, the U substitution we mentioned before. Replace the X trash, find a dx, then U du for these great effects. So, instead of just trying to like push it through as it is, because it would take a long time to figure out like all of the stuff that's involved, we're just replacing that entire section of function by pretending that it's something else. So it's like saying like if x plus or minus or x plus 2y squared, if that's like the whole thing that we're trying to derive, instead of trying to like do that all written out, we'll just pretend all of that is just the letter u, and then we'll just derive u as we normally would. So we basically replace some math with other math to make it easier. Calculus is a terrible thing for these great effects. So you do that for better reward. As all of our old x will be inducted in after integration checks, better than be vexed. So rather than being frustrated by the difficulty of the process, you can do that. So U subs are done. What's next? No more U du, eject. So, you know, get rid of your fake function. You're back to the normal one. Ejecting variance. We progress on to the list of subjects, and then in calculus, when you find the derivative, you're going down a step, but when you go the opposite direction, you are going up a step, but you miss a part of the function that isn't related to the variable. So it could be like, let's say it's x squared, the derivative is let's say it's like 2x, and then you go up, it'll be just 1x squared, but we're missing a chunk of that function. In mathematics, you can just literally not know what that number is. So if the derivative, like if the data that you draw from the original thing that you're trying to get, if that's something that's offset in some way, you don't really have a way of knowing it. So it would be something like the x squared is 2x plus some letter c of numbers, some count that we don't know. So, with that lore, that deep lore foreshadowing, after U subs are done, what's next? No more U to U. Ejecting variants, we progress on to the list of subjects. Don't you dare forget C. Constants lost can be tense. Downgrade your tests. Don't dare forget C. It'll throw your whole thing out if you don't remember that there could be a C there. You'd be missing some damn number and suddenly you're failing. Don't you dare forget C. They leave C stray and lose their way forgetting C. So people that don't keep track of the letter C, they're fucked because they're missing a chunk of the equation that could theoretically exist. It's kind of like imaginary number I, like you know how in math there's that imaginary number. That's kind of what C is in calculus, but instead of multiplying, it's just adding the letter C.
Yeah.
You get a thumbs up, pat in the back, and you'll find solutions if you don't every day forget C. So you'll get your answer if you remember your goddamn C. Wait, forget C? What you mean forget C? Next page. Want general solutions? Keep the C. But if you got everything you need with a particular solution, then you can solve for the C. Basically, C is solo while you kick other numbers to the curb, and wow, now you have C. So basically, because you have the imaginary number C, you can fill in chunks of the rest of the equation with whatever amount of information you have about your graph you're calculating, that you're calculating for, what have you. And you can basically reverse math to try to figure out what C actually is. So if you're keeping it general, like it's a rule of thumb, then you don't need the C. You can just leave it as the letter C. But if it's something where you're trying to find like, oh, I need to know where this point on the graph is, then you have to do reverse math and find the C. Basically like normal algebra, where it's like 1 plus 2 plus x equals 4. Well, if you move it to the other side, 1 plus 2 is 3, 3 plus x is 4, you move the 3 over to the other side, so 4 minus 3 is 1, so x equals 1. You do something like that in calculus for the letter C. Because I'm beginning to feel like a calc god. All my nerdies from the A to the B nod. Hey, new prob, when x is the exponent number, it's not number, it's a light R, it's not a hard R. Log natural, it's like a natural log, but, classy, French. Log natural enters king of salvation math god. So if you have a number where your exponent is what you don't know, or is the part that can change on your graph, let's say, for example, it's 1 to the power of x, that means that it's 1 to the power of 1, 1 to the power of 2, 1 to the power of 3, so on and so forth. With 1, that's pretty easy because it's just 1 multiplied by itself forever. But 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, that's something where that would make an exponential graph, but it would be demonstrated by 2 to the power of x. So differentiating this odd x, ln being log natural, or the natural log, ln gets past your math clog, because it's a little bit weird because you're doing a different thing. When your constant, enter your constant, wait, now put in your ln, suddenly heaven. So you do the natural log natural function ln in order to get to your solution. Ax, and then your ln immediately with constants you're holding, and if your hand is folded, you can change the base, go calc it out, erase your case, you got solutioned. So in short, basically, calculus is full of cheating, wherein you pretend like whatever it is that you're trying to do is kind of flip-flopped on itself a little bit, because calc is weird. What's even weirder is the fact that Isaac Newton came up with calc, and then algebra came after that. Like he went through to make calc first, and then we got algebra. And technically speaking, your calculus is easier, but we learn algebra first, which makes it inadvertently harder. It's really weird. Uh-oh. Connor, did you disconnect? Have I broken you? Oh no. Oh no, Connor. Connor? Oh boy. I don't know what to do at this point. Oh yeah, I'm looking at filing cabinets. Here's Bo-Katan. Here, you can look at Bo-Katan. Connor. Connor, where have you gone, my friend? Hello?
Okay. I guess Discord's just like, nope, we're just gonna disconnect you now.
I'm like, where did you go?
I was like, what the fuck?
All right. Now that
I
you're
didn't even
back.
realize I was disconnected. I thought it was you, and then you messaged me, and I was like, oh, wait a minute.
Anyways, so I'm like, where did you go? I don't know. All right, so back to the rap, as it were. So with a to the x, you use a log natural in order to figure out how the hell to do that, and then you calc it out, which basically means you just slowly start crossing things out as you go until you've got the solution. All right. But we got more rhymes of floatin'. That is pretty much almost a word for word ripoff of Rap God, with the exception of one of the words is swapped out. Don't wipe your sweat, tears, pain, drool. Differentials can get near chain rule. Chain rule is a rule in calculus that, I'll be honest, I don't remember very well. I think it's you have a function of a function, which gets real weird. So, I'm trying to remember how this goes to the beat. But we got more rhymes of frotin'. Don't wipe your sweat, tears, pain drool. Differentials can get in your chain rule. Got function in another spray and pray. So you must pay homage, pupil. Easy. It's a deriv drive through. Making deriv cake fool by leaving innards of our entry school hole. Differentiate outer power. So I'm trying to walk through the differential of chain rule, which is you're deriving a function of a function. That one's really weird because it'll be like, what is the function of a to the x? And then what's the function of that function of a to the x? So like if you had a to the x and it's part of a different function, you have to use chain rule because there's multiple functions at play in this goddamn calculus. Differentiate our power, then take the derivative of function within inception, chain rule and chain rule, the inside until you get it all before you reach the end times. So before the world ends, you gotta just chug through it. And if you stumble, like, what if sine enters the situation, it applies. So if you have like, if you remember sine, cosine, and tangent in math, you can have, that's when like chain rule would come into play because you're taking functions of functions, which is real gross.
Yep.
So function it out, and then in for answers, and try to not die. There we go. Loot. So it's a not die, loot the, because Eminem has those like split words to hit the rhyme. Try to not die, and then it's also a pun of just not dying. Not die, loot the whole thing, comply for the F prime, just do it once, not I don't know what I said here. It looks like it says those. Oh, I see. Alright, never mind. It's another continuation, kind of like dilute. Alright. Dilute the whole thing and comply for F prime. Just do it once and not 1,000 times. It's just straight from Eminem. It's just one fly for each function, not 5. So make sure you are only doing it once for each function. Don't accidentally do it multiple times, otherwise you're going to fuck up your answer. But sigh, if I were to shy if I were to shy in more deriving, the answer would come out a lie. So just reinforces the previous point. It's similar to the Clinton guy going on TV. That's a reference to the original Rap God. Like, it's not right. I did not. And then in the background, for this, I'd like to imagine that it's the quote from Clinton being like, "I did not have sexual relations with that woman." So, but sigh, if I were to shy in more deriving, the answer would come out a lie, similar to the Clinton guy going on TV like it's not right. I can't define every option, just look at it up on Wi-Fi. So sometimes if you're really struggling, just Google it. But hey, I'm going to instruct the second prime. So when you derive, or when you have if you have a derivative of a function, and then that's that function prime, if I'm remembering correctly, and if you derive it again, that's the second prime. Which inadvertently kind of means that Optimus Prime means that he's theoretically just the optimal function, or like derivative of a function, which is kind of a fun.
Yeah. Well, he's the derivative of Ultra Magnus, who's like the original like Transformer Autobot guy.
Yeah.
So he would be the optimal derision of the original.
So really, we're just acknowledging that Transformers.
That would be correct.
Has some wittier.
You would be correct in that statement.
Some wittier ass like freaking intelligence going into it. It's like South Park or Simpsons writers being way overqualified for their job. Anyway, I'm going to instruct the second prime.
There's a really good TV Transformers series on Netflix, by the way.
I did not know that.
I guess that's Canadian Netflix, though, so maybe
that's
shouldn't say that.
I don't really look at Netflix all that often. Anyway, so once you find dy dx, differentiate that as you would before. It's fine. That's how fine and easy it is to just find. I want to point out the triple rhyme there. Find, and find. Nice. Find derivative twice, second prime. For more, it's the same old chore. Bore easier than Mordor. One does not simply walk into Mordor, so it's actually not that easy. Is what I'm. It's a satire of itself, right there. You're able to do this core thought as thought many times for sure. So here's the basics. And you know how the hell to do much more. Your potential is not dull. Optimize or roll boxes to full. Fill it up to full. Fill it up to full if you want to, do it to the beat. Get your dimensions and play differential function just to get crit points and set to 0. Solve in the main way done. And then set your crit points right in the variable and find the maximum to placate your stressed brain. So we've done some theoretical mathematics just then, wherein instead of trying to find a particular solution, now you can find multiple solutions by, instead of having your limit set to infinity, the limit is set to 0, so it approaches, so as the number approaches the number 0, you're hitting a set number or set part, if I recall correctly. Plan your plan with that max number, because when you plug it in, that's what fate. There it is. It's kind of hard to read. This is some old ass paper. Plan your plan with that max number, because when you plug it in, that's when fate will pull what fate you'll place in. You'll rate plate and your hope for the highest volume. Let's go back. Ways for the math under the curve. Here's trap and sims approximate for the rhyming scheme. So that's the way to find the area under the curve if you start subbing in for 0. Because theoretically a curve on any graph, if you enter in 0 for that, like as any number approaches 0, you're going from negative infinity to 0. That's going to be the underside of whatever curve it is that you're looking at. While if it were 0 approaching positive infinity, that would be the upper part of whatever curve. And that's how you calculate the area of a curve above or below the graph, is where the number is approaching from and to. Yeah. So, where was I? The fast part. We'll break it down slow, and then I'll trip over myself as I try to do it again. Summa lotta numba lumba you are using for the Simpsons, the Simpsons approximation. What you got to do to get it through to you, it's math you're using. Take summation starting with the first, then take 4fy 2f 4fx 2fx 4fx 2fx till the last. Then you're remembering, gonna wanna make sure getting answers near the integration. After all, this is only approximation. Just to close in, same goes for the trapezoidal, different kind of function. Plug in and be done. Go over with integrating for a close answer. Double checking for the day you can say you got it pretty close, celebrating, because that is the way to remember. This is the way. That is the way to remember, or no, this is the way to remain motivated. Don't need an exact type answer, just need an intact like answer. So with Simpsons approximation, you're not going to be, it's kind of like trying to find it's trying to find like a definite answer for pi, or a definitive number for pi, when it's like an infinity, it goes on forever type thing. You can only kind of get close to it. So with some graphs, you're just going to have a hard time. So you have to do an approximation of that graph. So you use math to pretend that you know what it is, because it's only kind of there, but it's not fully there. That's math. There are no set answers. Everything is a lie. So to say it at a faster pace, summa lotta numba lumba you are using for the Simpson. What you gotta do to get it through to you, it's math you're using. Take summation starting with the first, then take 4fx 2fx 4fx 2fx till the last. Then remember, gonna wanna make sure you're getting answers for the integration. After all, it's only approximation. Just to close in, same goes for the trapezoidal. Plug in and be done. Go over with the integrating. For a close answer, double checking for the day you can say that you got it. It will be pretty close, celebrating, because that is the way to remain motivated. Don't need an exact type answer, just need an intact like answer. But this is confusing, is my next line, which is very fair, because Eminem would have said that very, very, very fast. And it is confusing because it's fucking Calc. Well, that's up to you. You have probs because you're a doofus. That's just some playful banter. It's not that hard, just lots of different likes in types of concepts, like odd even functions. odd even function rules that you can utilize for abusing. So basically, somebody comes by, doesn't know what the hell's going on, and the Calc god explains that in fact it's not all that hard, because it's really not. It just is a lot of work, and that kind of sucks. But once you've got an idea, then you're good to go.
Once you get the idea,
once you understand the core mechanic at play, then really you're not even doing number math all that much. Like in algebra, you'll have stuff where it's like, what's the square root of 144? Well, it's 12, but how do you get to that? Like, without just memorizing it, which apparently I think I've done, because that sounds right. But yeah. I don't think is it? Yeah, it is right. Okay. Yep. So without just outright memorizing it, how do you do the theory of numbers instead of like saying every single equation number that you're ever gonna do? Like, basically calculus is the way that people decided, hey, we're just gonna figure out how to do math without actually doing math, which is weird. And that's not even like number theory. That's just like a step in the direction of number theory. And God, I hate number theory. Okay. So what do I do for that? I don't know formulas to use. Let me be clear that occurs when you go unknowingly to new stuff that embraces or faces you. Close curtain and give up unless there's fate in you. There's always answers that shall come forth to you. Doing this cool prob is an interesting tool that takes calc in 3D in a 3D pack mule. Basically, he's trying to be inspiring, but then he's gotta have the same angst as good old Marshall Mathers, as it were. Calc monkey grades flunking, but look here to fill the shape. Just go plugging in the function, integrating. Play in the game with pi placed. Huh? Play in the game with pi placed in for volume ways. There's 3 in all, and they are disk washer and the shell. I think it's a disk function and a shell function is what that is referring to. Shell, way to gain the whole thing. But for this volume, I say you play out the lame disk, way to ascertain the number, my man. Then compare hand in hand. Wait, so it's pi units? Yes, that's a thing that can exist. So it's pi units, but on area there's no way to find n units to win. You can't have a definite answer if you have the number pi involved, is what that's basically saying. When pi gets involved, it's better to eat it than to calculate it, because you're gonna just have a bad time. So if you want like a definite answer, you can just get as close to pi as you want to go, but that's really about that. So wait, so it's pi units, but on area there's nothing, no way to find n units to win. I've been working endlessly. I just gotta understand to fill beneath. Well, eliminate what you know about space, because this great math example is made into a sensation to watch, because fate has that this whole day's been you working on this is a waste, because function L over X is a paradox in that it has a finite number volume but has infinite area due to the nature of the problem. Unlike volume of a lake, where will just take you to take you to fill what break it's not placed in. Uh, Basically, there's a function that exists where I think it's called like the cornucopia function or something like that. It's basically like if in math there are exceptions or weird things. Technically speaking, if you were to try to take a function that goes on infinitely and then make that a 3D volume thing, in the real world, how it would work is you've got like a cone and you can just fill it with water. Well, with this particular function, you have a like a cornucopia type horn type thing wherein you have only a set amount of volume. You can only fill it so much, but for the surface area, the area on the outside of your cone, the outside of your shape, you can have an infinite amount of surface area, which logically speaking doesn't make sense. How do you have infinite place to draw on the side of the shape, but you can only fill it with so much paint? Is kind of like the idea.
Like a fractal.
Yeah, so that's what the fuck that is. So unlike the volume of lake where you just fill it, fill you break. Wait, hold on. Unlike volume of a lake, we'll just take till you break. It's not placed in boundaryable. It's not placed in boundary. Able to make it calculatable. It's infinite. Just take a vacation. It's a big thought. So what I was saying is it's very complicated and very weird, because it is. You'll never fill up. This is the next line. You'll never fill up that space. Just don't be a student or a nerd. Think not. Why be a nerd when you could be a god?
Yay!
I wish. I'm sure I do. I wish that I knew where to find what limited video footage of this goddamn rap I do have. Because
I think we're all just, gonna have to disagree with you hard on that one.
Well, here's the thing. Like, the rap itself is supposed to be very informative. I believe, the original requirements of the project. Because our teacher, Mr. Whalen, bless him, decided that we were having a hard time, and if people wanted to, they can make an extra credit final project. And that's what we did to, make up for our grades. The purpose of the project is an opportunity to explore a topic of interest in calculus. It's an opportunity to do something fun using skills you've learned in class. There's no limit, pun intended. He wrote that literally in the thing. There is no limit to what you can choose, but all
calculus
topics.
Teacher. Yep, gotcha.
But topics must demonstrate content knowledge and skills acquired throughout the course. You should consult your teacher regularly throughout the project. He or she has a lot of experience foreseeing pitfalls and steering projects in directions that will be fruitful. The report should be in lab report form unless permission is granted otherwise. Should include a title, abstract, materials, methods, data analysis, sources of error, percent error, conclusion, and a short reflection piece. If you don't understand what's expected, you should see him sooner rather than later. Groups will be allowed for the number of individuals being proportional to the difficulty or complexity of the task at hand. For groups of more than 4 will require special permission. For this one, it was 3 people, so we didn't need permission. It was just myself, David, and Matt. And poor David had been subject to my insanity before, wherein we made a biology project that was a music video, and it was just DJ God Has Fallen in Love Again by Usher, except it was for biology. So it was like DNA God Has Formed Our Whole Species instead of DJ God Has Fallen in Love Again. And while I was Usher, naturally I was the dancer, so I was Usher. David, being the tough guy, that is a little bit more stoic in his face. He had to wear a bunch of beads and rap out the part for Pitbull in the song. So David was experienced with my torment. So with this project, as time that biology project was freshman year, and since then we had a burgeoning friendship. For this last project, the finale of our school experience together, we had Matt, who is a very quiet introvert at the time. I have no idea how he is now. I believe he went up to Minnesota for school, or North Dakota, or he went north for schooling. I don't know. I haven't checked on poor Matt in a very long time.
God, I would just hate to know. I really need to know though if he's in Minnesota. I
assume
know.
he's alive and well.
I don't know if we can. No, I don't know if we can just continue with this. I kind of need that knowledge.
I don't know how Matt is. I know
David's
David's married in Texas.
Call him and
Anyway, so
what's his wife's name? Zip code? We're in Texas. Like Austin?
Blood type.
These are vital details. I need. On my dating profile.
Yeah. So anyway, for Matt, he was very quiet, kind of like how David was. So the premise that we came up with was that we needed to decide on what exactly this music video was going to be, and we were going to make the full video, but that just fucking didn't happen. So we just made the rap and some of the video, but we ran out of time because with senior year, your year's shorter so that you can get graduation happen on time. So that was our group of 3. Now here are suggestions that he had for what to do. There's a trooper problem. You get a dog, a swimming dog, go to a lake, you get a floating kind of frisbee, and you calculate his or her speed on land and at sea. You toss the frisbee at several measurable angles and measure the time it takes for the dog to get the frisbee from the water. Plot the data.
Jesus
see if the dog is
Christ.
See if the dog is a calculus genius or just an old point and shoot kind of Fido. So basically, it's because this is technically how we determine. Like when I'm looking at a car and seeing how far the car is away from my current position, and I speed up or slow down, that's calculus at play for my brain intuitively knowing whether to speed up or slow down. Technically speaking, the faster you're able to process that information, the better at calculating that perceived distance you are, kind of thing. So that's what that one is. The next one, fold a box, get several pieces of cardboard, build a box by cutting out 4 small squares and folding the edges. Using rice or some other particulate solid, fill the box and measure the volume of the rice used. Do this for several sizes of square cutouts. Plot the data and see if there's a minimum where it is predicted using calculus. So basically, you do the first chunks of measuring the surface area of a particular shape, and then the volume of a particular shape, and you determine if it's a function or not. Which, because it's determined by calculus, if you did everything correctly, yes, whatever surface area you have, volume would increase a little bit more. It's I think it's a logarithmic function. It might be an exponential, but basically for a certain amount of volume, you're going to get much more surface area, and that happens every time you go up in size. So like I might have a single rice grain. The single rice grain is only one measurement, but the surface area is essentially like if it's a perfectly rectangular, it's 6 measurements. So it happens to grow a little bit faster as you go along, if I remember correctly. That sounds right though. Or it's the opposite. It's one of those two things. So you do that. Funnel fun. You get a big funnel or some other geometric shape. You fill it at a steady rate, like a garden hose. You measure how fast the water level rises. You do several runs and you see how the data compares to a theoretical value determined by calculus. Plot the measured rate of increase and compare that to the theoretical by taking the derivative. So you just do calc and see if it matches what it seems to be in real life. Mathematical modeling. Model some aspect of nature and see if your theoretical result is close to the actual data. Teach a pet a trick and model it with a logistic growth equation. Determine the trial number and the greatest rate of learning. So how fast can your dog learn a thing, and are they getting better at doing the same thing every time that you do it? Calculate the volume of Long's Peak. Use Google Earth to map out the peak beyond, say, 8,000 feet. Now model the mountain using some function. Assume the mountain is the same from all vantage points, and find the volume by revolving the solid about its axis. Calculate your percent error if possible. So just by taking a look at Long's Peak, do math to see how big it is in terms of volume by using calculus. Make a sculpture. Design a sculpture using a function or several piecewise functions. Make a large stencil. Find a pottery wheel.
I like how you're like, I'm not going to explain what natural logarithmic log that word functions are, but measuring the area of a mountain needed the paragraph dissertation. I got that one. I think I've managed on that one.
Okay.
Might have that one. Those are the kinds I got that.
Make a sculpture. Design a sculpture using a function or several piecewise functions. Make a large stencil. Find a pottery wheel. Build the shape. Calculate the volume and surface area. See if the results match.
Pottery wheel.
This is where he got like into the stuff that I was excited about, because it's not just like do numbers, but like do something else that's just not math.
Be
and
extra.
That's where I went, yeah, be extra. Do something that you're good at, that kind of thing. And this is the kind of stuff where I'm like, God, I wish teachers did more of this shit, because it inspires creativity while it's still being involved with whatever subject you're looking at. Make a sculpture. Find the area of an irregularly shaped object. Draw and cut out a function on a heavyweight material. Weigh the area. Cut out one square unit. Weigh that piece. Calculate the area under the curve of your function by using a ratio of the two and by using calculus. See how close your results match that are obtained by integration. It's missing a word there. That obtained. That is obtained. See how close your results match that obtained by integration. That's a weird sentence, but technically I think it works. That's weird. Okay. Design some jewelry or article of clothing, a mask, a hat, etc. We live in plague times. That word has a different meaning now. Good old masks. All right. 1. Design a ring of pendant using some mathematical function. Use techniques such as surfaces of revolution to determine the volume so you know how much cloth or metal you'll need. 2. Make a replica out of Play-Doh or some other material. Submerge it in water to see if your volume was similar to what you calculated. Determine the cost of producing that product based on the density and the current market commodity costs. Then wear your new fashion to class.
That one.
So that one's kind of fun. The next one, test the gravitational force of the Earth. Drop several objects from a given known height. Use this to model the position, velocity, and acceleration of a function as a function of time. If you really want to get down with it, again, pun intended, because it's falling. Drop spherical objects like marbles and baseballs and bowling balls and model the air resistance using some common models. See Google. Prove it. Find a collection of related theorems or general solutions to prove. If you choose this project, then you must be able to prove your findings live. Perhaps this is a summation formula. Perhaps it's a 3D formula like a sphere or a cone. Derive a new set of spherical cones that aren't bound by a line but are instead bound by some other function. Prove several of the derivative formulas like the power rule, the product rule, the quotient rule, natural logarithm. Prove that the rectangle rule gives the same result as the trapezoidal rule or Simpson's rule for a few functions. So you just do math and prove things are things. Get jiggy with it. Finally, teach others calculus the way it was meant to be taught, through poetry, soliloquy, song, or interpretive dance. If you choose this one, be careful. You will be held to the same standard of execution as all the other projects, so it should have props, lighting effects, a music video background with lyrics, and a changing background. This video must be educational and made available online. We did not do that, but I think we did enough of that it counted, and it was fine. New Calc trick shot. Learn another skill from another section of the book and write up a report on how to use it. This should be something like Les Hospitals rule, integration by parts, determining arc lengths, or integrating in 3D, something, etc., etc. So basically just do another chapter of the book. I don't even remember how much we touched of that book. Gabriel's horn. Don't try this one at home, kids. Make a model of Gabriel's horn and see how much water fits inside it. Now try to paint it. So that's what I was saying, where it's like you can paint the outside endlessly, but you can only fill it up so much. Scoring rubric. It should be about 2 to 6 pages, no more than 10. I'm summarizing a bunch of this. Try using the time measured by stopwatch, like make it impersonal, so not I, we, my, our. Group accountability. Each person is responsible for contributing to each section of the report. If I remember correctly, we basically had it so that I did the rap and we all participated in the video, but David and Matt ended up doing like the write-up part so that I didn't have to, because I was busy coming up with the rap and recording it, if I remember correctly. That was fun. Cover page, abstract that summarizes the report, the purpose of the report, materials, methods, results of the report, if there's any like particular calculations that we did. Conclusion. This section is also called the discussion, where you find major findings and quantitative evidence to support claims. Bibliography, if you have sources, there you go. Appendix, photos, afterthoughts, and reflection.
Jesus Christ.
So we made
sources
Calc God. So we made Calc God. Back to the thought of like make an educational video. We made Calc God. We recorded Calc God, and then we tried to film stuff for Calc God, and we only did like a little bit of it, but some of the things that we were looking to do were make the video funnier than the actual lyrics, because the lyrics are very, very dense, because Calc God is a goddamn long song. We originally thought we were only going to need to put in like a third of what we actually did for the lyrics. So for the video, we just kind of went ham. Now, because David had experience of being my poor dancing monkey, Matt, as the newcomer to this arrangement, was the current dancing monkey. So when the three of us filmed it, it was me in a black hoodie with glasses, with like 3D glasses with the lens popped out so that it looked like I was wearing glasses, and I don't remember what, I think cargo shorts, while David had the R2D2, or no, he didn't. David had a flat cap, not a baseball cap, but one of those flat caps for hip hop. Chains. I think he had like I think he had a tank top and sunglasses on, as well as like basketball shorts. And then Matt had shorts on, an R2D2 jacket, glasses, again with the thing like popped out if I remember correctly. And throughout the video would stick his front teeth out, so he had a super large overbite throughout the video, so he was just like so that's what Matt had. And the premise was that the Calc gods, i.e. David and Jordan, were teaching Matt, the nerd, how to be a Calc god. That was the premise. Some of the things that we wrote. One, we have a sped up version of solving one. I think it was 1 to the 3, and the function is x squared minus 2x minus 1 dx. That was the function for Calc.
1 to the way to the pair.
And then part of it is sitting Matt down and telling him to get practicing and pointing out the problem on the board. We say it to the camera. We lip sync to the camera and turn swagger on. I put that in quotes. Turn your swagger on. David and Jordan drop while Matt stands confused. Then they or girls. We were undecided, but we didn't have the budget for female representation. They or girls pop up as U replacements. That was very loud. Ow. So we just taped the letter U on our chest on a piece of paper. We do something sexy for the camera.
Yeah.
You got very loud. I need to turn you down real quick. It's like suddenly deafening.
Yeah, like that. No really sucks, young.
Anyway, do something sexy for the camera, quote unquote. BRG, brig, X on the board with Matt just staring at it. So just him looking at it and not knowing what the hell to do. I slap the board with the function dx popping up around X. So like one of those quick cuts where it's like you snap and it's the next shot type thing. One of those. We cross out a pair of the parentheses because we're doing math. Something about extra stuff sucks, and separate David, Jordan, and Matt setting up an integration problem, a flash of a really complicated problem. Those are like all the notes that I have from, I think it was Matt wrote this as kind of like brainstorming ideas for what we would do for the video. One thing in particular, actually two things in particular, I lied, there's 3. There's some memorable moments. Going back to the lyrics, because, you know, at the end of the day, you want it to be related to what you're singing. One of the things was get a textbook in your back pocket. And what we filmed was me and David with the calculus textbook literally opening up Matt's pants and trying to like shove it in, with him with this extraordinarily pained expression, just like So that was one thing that we filmed. Somewhere on there we talk about calculating the area under the curve, and so we had a whiteboard of a particular curve that like went up and down, went up down, like two bumps basically. And we drew that function out. I don't remember if we actually calculated it or not, but we had that as like the screen. You could see all of that on the whiteboard, and we lowered it down, and that curve happened to perfectly match how Matt was laying on the couch. So it was his curves. That one was fun.